So, welcome back to the the fifth day of the study live stream. So I actually have four live streams I've noticed, but one of it got blocked because I played music on my I played music during the stream. So I mean, I kind of expected that already. It's just it doesn't really matter because like literally you don't even get anyone coming to my live stream. So yeah, well, I can't say I didn't expect it, but yeah, today we're gonna do more physics. It's going to be the 2020 paper, this one. So we're gonna do physics 2020 paper 4.2. Yeah, so this time I'm just gonna play my music on my phone so it won't get picked up by my computer. Yeah, that sucks. I actually didn't expect to. I mean, I did say that I would get it, but I didn't expect to actually get it because like I thought when you like file a like to block a live stream, it's up to like the actual people to like come and see your video and be like, oh, this is my song and I'm gonna block it because you're playing my song. But I didn't know YouTube will automatically block it themselves. Okay. Okay, I'm gonna start now. You got a base. Okay, now man. Yeah, my paper 4 is in 2 more days. It's on the 9th of October, so I'm not counting the 9th. So yeah, it's coming soon. Additional potential. Work done per unit mass in moving a point mass from infinity to a point. B. I really hate drawing graphs. It's just really tedious. Okay. So for this one, because gravitational potential is equal to gmm over r, inversely proportional to r, so as r increase, gravitational potential will decrease. And as you move away from the gravitational field, you're moving away, you will get negative gravitational potential. Wait, no, positive. The further you are. So this one is change in gravitational potential, I think. So move away further, you get positive gravitational potential. So R would be, so since gravitational potential is equals to 1 over R, so R would just be equals to 1 over 1, so it'll be 1 gravitational potential. But if you double the radius, you'll get half of your gravitational potential. It should be 0.5. If you triple it, you'll get 1/3 of your gravitational potential. 1/3 will be 0.3. So I don't think there's a negative value here. And of course, if you have 0, you'll have 0 radius, you'll have 0 gravitational potential. Yeah, I feel like I'm doing this wrong, honestly. Change in gravitational potential equals to Gn over R minus Gn over R. Oh, potential energy instead of Gn, sorry. So firstly, you'll have final one initial, so it'll be 3R minus 4R, so 6.67 times 10 to the power negative 11. 1 over 3, 6.4 times 10 to the power 6, minus 1 over 4, 6.4 times 10 to the power 6. So 6.67 times 10 to the power negative 11 times 6.4 times 10 to, sorry, 6 times 10 to the power 24 times 3.4 times 10 to the power 3. times 1 over 3, 6.4 times 10 to the power 6, minus 1 over 4, 6.4 times 10 to the power 6. So you get a negative. Okay, so your answer would be 1.7 times 10 to the power of 10. Probably 1.8 since it's 1.77 joules. Only it'll be negative because you're moving directly towards you're moving nearer, so it'll be negative. But so yeah, I think the answer will be, oh my gosh, I just realized. Okay, so you since it's moving closer, 4r to 3r, it will be a negative. But since it just says change, then yeah, it will be negative. Explain whether the rock speed increases, decreases, or stays the same. So since PE, potential energy, is directly equals to kinetic energy, so since we have a decreasing potential energy, so that means that the loss in potential energy is equals to, as loss in potential energy, there is a gain in kinetic energy. Hence speed increases. Okay, let's move on. 2a. Let me just check some messages. Okay, so for this one, raw would actually be the. Hey, it already shows that the density. Oh, show how it's derived. Okay. Okay, so this one, since pressure is equals to 1 over 3n m over v times root means c squared, the density will be derived from the mass over volume from the equation, which gives you the density. And the 1 over 3 Oh, sorry, it's asking for how each of the following terms of equation 2 is derived from equation 1. Yeah. So first we just convert, let's just try converting it. PV is equals to NMV squared. So we have P, which is 1 over 3 NM over V C squared. which you can see from here. Yeah, it's here. Sorry. So here you do have a V there. Here you have a V equals to nmv squared. They would cancel out, which wouldn't give me a... Oh, sorry. My bad. They're trying to show that P is equals to that, so you don't convert it. So you just put P is equals to nmv squared over V. And that's your formula from what we get just now. But there is the 1/3, which I'm not sure where it comes from. It's probably from... Yeah, honestly I'm not sure. But I know that, therefore, density comes from mass over volume. Okay, N. What do you get from N? So N is the number of molecules. Let's just answer how root mean c squared comes from. Due to... So we just say it's the root mean squared. Root mean squared of particles as there are multiple. So it's just like the average from what I think it is. 1/3 is derived from... How do we derive 1/3? Okay, I don't know that one. So wait, let me think. N, something to do with the N. Yeah, I actually don't know. This is a tough paper. It's really tough. Where does the 1/3 come from? Okay, let's just move on. Calculate. Hopefully that's the last question I'll struggle in, because this is not going well. The mass of the gas is 20.7. Calculate the mass of one molecule of the gas. Okay, PV is equals to... Try and calculate the number of molecules. So NKT. P would be 3 times 10 to the power 5 times V, 6 times 10 to the power -3, divided by 1.38 times 10 to the power of... What's the Boltzmann constant again? 1.38 times 10 to the power -23 times the temperature, which is 17 degrees. So you'll convert it to Kelvin, which is 273.15 plus the temperature, which is 17, and you'll get your N. So the answer would be 3 times 10 to the power 5 times 6 times 10 to the power -3 over 1.38 times 10 to the power -23 times 273.15 plus 17. So from this you would get 4.5 times 10 to the power 23, but this is the number of molecules. Since the mass is 20.7, so you have 4.5 times 10 to the power 23 molecules first. So you have to times this by What's the kilogram? 6.02 times 10 to the power of something, I forgot. Oh no. Wait, no. 1.66 times 10 to the power of negative 27. Okay, times 1.66 times 10 to the power of negative 27. That gives you the kilos. Wait, is it that? I'm pretty sure it's like 6.02 something. Well, I guess not. Okay, and then from this, you get 7.462 times 10 to the power of negative 4, which is the kilos. And you go all the way back to the question, it says that it is 20.7 grams. So the next one would be 20.7 divided by 7.462 to find the mass of one molecule. Oh, my bad. This is so embarrassing. So in the beginning, you already found that there's 4.5 times 10 to the power of 23 molecules. So 4.5 times 10 to the power of 23 is equals to 20.7 grams. So therefore, you will find 1. You will get x equals to 20.7 divided by 4.5 times 10 to the power of 23, which gives you 20.7 divided by 4.5 times 10 to the power of 23. You'll get one molecule would be 4.6 times 10 to the power of negative 23 grams. That's your answer. Okay, next one. (3a). By reference to the first law of thermodynamics, they explain the change, if any, in the internal energy of a lump of solid as it melts at constant temperature. So since it's in constant temperature, there's no thermal energy supply. And it melts. However, it does not it doesn't vaporize, none of it is lost, and the volume would remain the same. Wait, no, sorry. Okay, let's just write down first. Since constant temperature, constant temperature doesn't usually mean that it's no temperature supply. It could just mean that temperature loss. Okay, yeah, basically it does mean that temperature loss is equals to temperature gain. So there's no net transfer, so it's just constant. So since constant temperature, no thermal energy, no thermal net gain, and therefore is equals to 0. However, as it melts, it does gain more volume. Like if it loses volume. It gains volume. Since if you think about it, it's like when you have a solid, all the particles are very closely packed together. But when you melt that solid, it starts to move apart from one another, which means that there's more space, meaning that you get more volume. So as the lead expands, however, since melting, gain in volume, hence so there's work done by the lead. Negative work done. Therefore, decrease in internal energy. Okay, next one. Some gas in a toy balloon when the balloon bursts. Okay, so when the balloon bursts, the gas is the one that's exerting force on the balloon. So that negative work done. So no thermal energy enters or leaves. Wait, this sounds exactly the same as the first one. The explanation would be about the same. So that makes me feel uncomfortable about my first answer. No gain in thermal energy or loss, hence 0. And since gas gains volume, work done by gas, hence negative, therefore decrease in internal energy. Okay. For A, show the angular frequency of oscillation of the ball in the dish is 2.9 rads per second. So we'll use this one, g of r, where g is the acceleration of free fall, which is 9.81, and r is a constant that depends on the dimensions of the dish and the ball. Well, I guess we don't have to use that since we already have this. So we find the period, which should be somewhere here. 2.2. Yeah, 2.2. So period will be 2.2 seconds, so your angular frequency will be 2 pi over t, which is equals to 2 pi over 2.2 seconds, which gives you 2.86 radians per second, shown here, which we've shown that it's round off to 2.9 rad per second shown. Okay, for B, use the information in A to determine R. Yeah, we use this one. So you know that 2.9, sorry, we just use 2.86 is equals to G over R. We know G is 9.81, so R will be equals to 9.81 over 2.86. .43 meter. Okay, next one. Calculate the speed of the ball as it passes over the center of the dish, going through here. So that would be, look at this, look at the graph here. X is 3, and when x equals to 0, that means right here, over here. So I think for this one, we just use v is equals to angular velocity squared x, not angular velocity x naught. Okay. Is that how it works though? Well, I guess that's how it works. Okay, let's just do that. V is equals to angular velocity x naught. It's not squared this time. Equals to 2.86 times, so the x would be x naught will be 3, because we know over here it's maximum speed, so x naught equals to angular velocity. V naught is angular velocity x naught, so x naught will be 3. So 3 times 10 to the power negative 2 just equals to 2.86 times 3 times 10 to the power negative 2. That's your max velocity. So it's 0.086. It's 858, so we round off the two significant figures. 86 meters per second. Okay. Although I'm not confident in that answer. Wait, let me think of a reason. Increase. So you'll get a V is equals to angular velocity x naught. It's decreasing in x. And then you'll get it's probably increase in speed. So yeah. Makes sense. I guess that makes sense. Max velocity, max displacement. Alright. Next one, C. Actually, I think there's a formula for that. I think it's V is equals to angular velocity x naught squared minus x squared. So you will take the maximum minus the one that you're currently on to get the, let's say you're at, the max is 3 and you're at 2. You want to calculate the speed at 2. So since we're calculating the speed at when it's at center C, which is 0 due to displacement, this will be 0, so that's why it's V is equals to angular velocity x naught squared. Let's just move on. Where is it? C. It's that big. Okay, so I'm actually answering this message. I sent my MacBook Air 2018 that I just bought to one of the Apple resellers in Brunei, and because I was trying to repair it myself, but it keeps having like this error 1008F, which from what I saw online, it's due to activation lock. So I just wanted to confirm with the store, of course, and they're saying it's just due to bad internet connection, but I'm pretty sure my internet connection is quite good. I've been using it right next to my router as well to install the OS, but it keeps having the 1008F error, so I'm pretty sure it's activation lock. Or maybe I should boot up with the external drive, but I'll see first. Maybe when I collect them, when I collect my MacBook, I'll experiment with it more. On the axis of figure 4.2, draw a line to show the likely diameter. Let me just message because I asked the guy to deactivate it, and let's see what happens now. Okay. Oh, he immediately saw my message then. Okay. Explain the principles of detection of ultrasound. Okay, detection. You don't really. Oh, sorry, I haven't even done this question yet. Slightly down motion for the first 5 seconds. So since it's down, you would just draw like first one, and then you stop a bit early over here. Then up, and you stop a bit earlier over here. And then over here a little bit earlier, earlier, and all that. Yeah, so that's basically how it goes. Just like that. Okay. Next one. Yeah, then detection of ultrasound. I remember doing this, but I totally forgot. Okay, you have to mention the ultrasound waves. And let's mention the piezoelectric crystal. Okay, piezoelectric crystal emits ultrasound wave in range of natural frequency when PD is mass. Another one would be it asks specifically for detection, so you just give the detection once. Pierce detector on piezoelectric crystal detects the waves reflected of different intensity. Yeah. The point would be varying intensity of detected waves provide contrast, comma, how do I make it more professional? Provide nature of boundaries. And fourth, we would say distance between boundaries measured by time delay between emission and detection. This is a really tough paper. The reference to specific acoustic ingredients explain why there is very little transmission of ultrasound waves from air to skin. So I think this is because oh man. Air and skin have very different specific acoustic impedance. You mentioned the ratio. Ratio is ratio is close to 1. Therefore, most of the wave gets absorbed. Only very little intensity most of the wave gets absorbed, hence only little transmission. Now let's put transmission, but in the exam you'll put little transmission and be specific of ultrasound from air to skin. Okay, 6A is not in the syllabus. Move on to 7. Let's continue. I'm talking back and forth with the technician right now. They're saying that they can proceed with the installation. However, I'm trying to save money, so I'm not gonna pay for the macOS installation. But how come I can't proceed with the installation? Maybe I'll use Ethernet next time. Cause like the receivers on MacBooks are actually quite good. Cause like I had a 2012 MacBook Pro, and the receiver was like better than my Razer Blade 2019. So let's move on. Let's learn about electric field strength. Force per unit positive charge. I think it's just force per unit positive charge. I think one mark is just force per unit and another mark is positive charge. B1. Use figure 7.2 to determine the radius of the sphere. Explain your working. So for this one, you would just do I don't know what's 2 marks honestly. 0 to 4.12245. 4.5. Radius is equal to 4.5 cm, and you would say that no electric potential within sphere. Electric potential at surface of sphere. Okay, next one. V2. Use figure 7.2 to determine the charge Q on the sphere. Yeah, so this one we'll do V is equals to Q over 4 pi E naught R. Oh no, it's electric field strength, so square. No electric field strength within sphere. So let's start at 4.5. You know, E is, I haven't measured that. 1, 2, 3, 4, 5, 6. 6 is 0.5. 0.5 times 6. 3. So it's 18. 18 times 10 to the power of 5 is equals to Q over 4 pi 8.85 times 10 to the power of negative 12. Negative 12, right? Negative 12. Negative 12, and R square would be, just now I measured it, 4.5 times 10 to the power of negative 2 square. Since this is meter, you'll have to convert it to meter as well. So then Q will be equals to 18 times 10 to the power of 5 times 4 pi E 8.85 times 10 to the power of negative 12 times 4.5 times 10 to the power of negative 2 squared. So answer, your Q will be equals to 4 times 10 to the power of negative 7 charge coulombs. Okay. C, an alpha particle, is situated. So for C, having the alpha particle 8 cm away from the center of the sphere, calculate the acceleration of the alpha particle. So calculate the field strength. 8 cm away, the field strength would be sorry, 8 cm. Around here, so it's like 5 point. It's the middle. 5.5. 5.75, around that. Just guarantee it. Yeah, 5.75. 5.75 times 10 to the power 5, that will be your electric field strength. The field strength would be 8. Like what we calculated just now, 5.75 times 10 to the power 5. However, the alpha particle has its own field strength as well. Okay, so we have to calculate the field strength of the alpha particle. But we don't know the R. Let's say it's force, it's about 8. The center would be, okay, the distance away would be 8 minus 4.5. From the center it will be 8. Let's just take 8. So the alpha particle has a charge of 1. Is it 1? That's alpha, right? Wait, alpha is 4.2. Pretty sure alpha is a 4.2. So you'll have a 2 charge, 2 times 1.6 times 10 to the power of negative 19. 2 times 1.6 times 10 to the power of negative 19 over 4 pi 8.85 times 10 to the power of negative 12 times the R will be 8 times 10 to the power of negative 2 squared. So the electric field strength would be 2 times 1.6 times 10 to the power of negative 19 over 4 pi times 8.85 times 10 to the power of negative 12 times 8 times 10 to the power of negative 2 squared. You get 4.49. Oh my gosh. Field strength is... This is really hard. Jeez. 8. So we get 1.5. So I'm wondering why it's a negative 7 field strength. 10 to the power of negative 7. That's really small compared to this. Hold on. how else would we calculate? Do we just do mg? F is equals to ma, so the G will be equals to the field strength. So electric field strength will be equals to G. I guess we will, since we electric field strength is V over D and it's also F over Q. Just okay, so let's take that. Field strength is 5.75 times 10 to the power 5, and the charge of alpha particle will be equals to, so we find the F first, so 5.75 times 10 to the power 5 times 1.6 times 10 to the power 19, and since alpha is 2, you have 2 electrons. 5.75 times 10 to the power 5 times 2 times 1.6 times 10 to the power 19, and we have equals to 1.84 times 10 to the power negative 13. From here, you would do MA. So you have 4 bits, so A is equals to 1.84 times 10 to the power negative 13. 13 divided by 4. For unified atomic mass would be 1.66 times 10 to the power negative 27, right? Yeah, 1.66 times 10 to the power negative 27. Okay. Divided by 4 times 1.66 times 10 to the power negative 27. The answer would be 2.7. This is a very big acceleration, 2.8 times 10 to the power of 30 meters per second squared. Yeah, that's a very huge acceleration. Okay, excellent. But I'm the most confident in that. I'm quite confident in that answer. So 8 is not in our syllabus. We don't learn about like bandwidth and all that in this current syllabus. H. State and explain the direction of the magnetic field. So it's an electron, since it's pushing the electron down, you would assume that electron will be always attracted to the positive side, so the magnetic field would be normally it'll always be like the positive going towards the electrons, so it'll be downwards, no, sorry, upwards. So the lower side will be the positive, the top side will be the negative. So that means the electric field will be upwards. Sorry, magnetic field is upwards as an electron is attracted to positive terminal. However, in magnetic field, oh my gosh, No, that's an electric field. It enters the uniform magnetic field at right angles to the magnetic field. Traveling at right angles to the magnetic field. Yes. Alright, so it has to be vertical. So it's upwards. Positive, move towards negative. Oh, show the speed. Oh. Show the speed of the electron is 9 times 10 to the power 6. We have the magnetic field of flux density 8 times 10 to the power negative 4. So from this, you initially the electron is traveling in right angles. BQV. No, you can't use BQV. You have the arc. So mv squared over r. The force is equals to BQV. You don't have the potential difference. So how would you know? You can't use BQV. We know the mass of the electron. We know the mass of the electron, and we know the magnetic flux density. We know the charge of the electron. However, we don't know the potential difference. That's making it really tough to answer this, because normally I'll just use BQV is equals to mv squared over r, but you don't have to be. What's another formula I could use? Oh my gosh. BQV is equals to mv squared over r. Okay, I have to search this up. Let me search it up. Formula for magnetic force. It's saying BQV. The V is particle velocity. It's not potential difference. But which one is it that asks for the... Wait on. Yeah, which one is it that asks for the potential difference? BQV. So remember, sometimes it's the potential difference as well. It's V and BQV. Speed of particle. Yeah. But last time I did speed of particle and said it was the potential difference. Is it interchangeable? I don't think so. No way potential difference is equals to velocity. Is it though? Well, I guess it's interchangeable since even for like that doesn't mean it's how do I say it? Interchangeable. That just means that it's proportional. Okay, so whatever. Now we know that it's V is the velocity. You could move it here and they will cancel out, so you just get mv. So BQR over m is equals to V, which is equals to 8 times 10 to the power negative 4 times 1.6 times 10 to the power negative 19 over, sorry, how times the radius, 6.4 times 10 to the power negative 2 over m, which will be the rest mass of electrons, which is 9.11 times 10 power of negative 31. V will be equals to 8 times 10 to the power of negative 4 times 1.6 times 10 to the power of negative 19 times 6.4 times 10 to the power of negative 2 divided by 9.11 times 10 to the power of negative 31. Nope, we don't get the answer. Oh wait, we do. 8.99 times 10 to the power of 6. 1, 2, 3, 4, 5, 6, which is rounded off to 9 times 10 to the power of 6 meters per second. I don't think I'm ready for A2 yet after doing this paper. This paper is so hard. The uniform electric field is now applied in the same region as the magnetic field. An electron passes undeviated through the region of two fields. On the field 4.9.2, marking the arrow the direction of the uniform electric field. So since the path of the electron is now no longer deviated, that would mean that there is no force acting on the electron anymore, meaning that there's no force acting on the electron. So in order for there to be force acting on the electron, you will need the current going in to be perpendicular to the magnetic field and along with the electric field. So it has to be perpendicular to the electric field as well. So that means the path of the electric field would be horizontal lines. So it's no longer the path of the electron is not perpendicular to the electric field lines, meaning that there is no force acting on the electron. Yeah, and I think for the 9A1 it's supposed to be downwards, not upwards. Makes sense now. It's supposed to be, and since the electron is deviated downwards, it will only make sense if the field is, okay, so let's say current's going in here. In order for the electron to be deviated downwards, to revise some of this. Use data from A to calculate the magnitude of the electric field strength. My brain. Electric field strength is equals to force per unit coulomb F over Q. Is data and writing. So I know the electric force, the electric field strength. Oh yeah, so since electric force is equals to QQ over 4 pi E naught R squared, for electric field strength you will just have to take the electric force from just now, BQV, which is 8 times 10 to the power of -4 times q 1.6 times 10 to the power of negative 19 times the speed, which is 9 times 10 to the power of 6, divided by the charge. You need two charges. That's for the force. Oh my gosh. Oh. I don't think I'm doing it right, but you will just divide by 1.6 times 10. No, it's not right. Let's skip that one first. Sorry, I really don't know how to do it. I know it's like something to relating the equations. 8 times 10 to the power of negative 4. I think maybe we just do. Oh my gosh. I'm thinking too much. That's the problem. We just use the formula. Q over 4 pi E naught R. That's it. Sorry, R squared. That's it. That gives you the electric field strength already. Oh my bad. So it's 1.6 times 10 to the power of negative 19 over 4 pi 8.85 times 10 to the power of negative 12 times r squared, which will be 6.4 times 10 to the power of negative 2 squared, which would give you 1.6 times 10 to the power of negative 19 over 4 pi times 8.85 times 10 to the power of negative 12 times 6.4 times 10 to the power of negative 2 squared. Field strength would be 7.5 times 10 to the power of negative 7 minus per coulomb. Okay. Next one. C. Replaced by an alpha particle. Since alpha particle is 4 times the mass, 2 times the charge, it's traveling the same speed, so it has a greater momentum since the mass is higher, but a lower acceleration. So it finishes with a lower speed, but the shape of the path should still be the same. If you can't explain the answer, then yeah, it's probably wrong. Traveling at the same speed, so alpha particle is traveling at the same speed. What do you get when it's traveling at the same speed? Higher momentum. But will the path differ? Probably the same path. As the charge is double. So that means that you would get a stronger force of attraction towards the lower deflection. But you are traveling at a faster speed, so you have a deceleration. So yeah, probably that's why it has same path as higher deceleration. Okay, next one, number 10. This one's a bit more familiar. Let me turn on the lights. State Faraday's law of electromagnetic induction. Induced EMF. Oh, sorry, no. Something about change of. Okay, induced EMF is directly proportional to the rate of change of magnetic flux. It's not direct proportional, it just equals to the rate of change of magnetic flux. And I remember there's something else we have to state. Magnetic flux linkage. But I remember there's something else. Yeah, I think the first one is rate of change, and then the second one is magnetic flux linkage. Okay, we'll just leave it at that. B. Wait, we didn't transformers. I mean, technically it is in the syllabus. I mean, okay, sorry, my bad. It is. Function of transformer is to convert AC to DC. Number 2, because current that comes in is AC, but your appliances can use DC, so that's why you need a transformer. Sinusoidal alternating current in the primary coil gives rise to varying magnetic flux linkage in the second coil. Use Faraday's law to explain why the output from transformer is an electromotive force that is alternating. So the electromotive force is alternating. So this is because alternating current it already says that it gives rise to a varying magnetic flux linkage. To a varying magnetic flux linking the secondary coil, so it already states that it's cutting, so you don't have to state that again. Alternating current causes changes in magnetic flux, hence when second coil cuts flux, induced EMF constantly changing as well. Hence, alternating EMF. Okay. Explain why the soft iron core is laminated simple to reduce eddy currents, which is heat, because it provides heat. It's to produce the increase in efficiency, basically. Okay, so we have question 11 and 12. 11 is not in our syllabus, but B is. But we don't learn about band theory. The structure of a copper crystal is to be examined using electron diffraction. Electrons are accelerated for residual potential difference. The de Broglie wavelength. Oh no, it's probably not. Yeah, it's probably not in RCMS. Sorry. Not in silver. 12A. Mass defect. Like, sometimes physics, you get what it means, you get what it is, but you just don't remember like the exact wording for like, yeah, for the term. Mass defect. Do I just write difference in? Yeah. I actually don't know like the exact term. Difference in difference in molar mass and individual. No, this is wrong, but sorry. I just don't know how to like write the exact name, the exact wording for it. Okay, V1 state that the energy equivalence of 1U is 934 MeV, so this one you just, the mass defect is 1, so E is equals to 1 times 6.02 times 10 to the power, my bad, 1U is equals to 1.66 times 10 to the power of negative 27 times 3 times 10 to the power of 8 squared. E is equals to 1 times 1.66 times 10 to the power of negative 27 times 3 times 10 to the power of 8 squared, which gives you 1.494 times 10 to the power of negative 10. And you would, since you want megavolts, you will just divide this by 1.6 times 10 to the power of negative 13, which will give you 1.6 times 10 to the power of 1.6 times 10 to the power of negative 13, which will give you 933.75, and we round off to 934 electrovolts. There we go, it's shown. You know, like you do these more simpler questions, your brain just relaxes. Those questions just now, they were giving me a brain stroke. Okay, on to the binding energy per nucleon of a helium-4 nucleus is 7.49, so binding energy is basically, you still use E equals to mc squared, but for this time you have to get the mass defect, which is to 4.001506, just don't round off, just leave everything in there, plus, minus 4, not 4, since it's 2 proton, wait, my bad, 2 proton, there's 2 proton and 2 neutron. So 2 proton would be 2 times 1.07276 plus 2 neutron, which is 2 times 1.008665 and times 3 times 10 to the power of 8 squared, which gives you 4.001506 minus 2 1.007276 plus 2 1.008665. That should give you an answer. That should give you a mass defect, not the answer. So I have to add another bracket, which is a mass defect of 0.030376 times 3 times 10 to the power of 8 squared, which will give you 2.73 times 10 to the power of 15. Wait, no. Oh, I forgot to times it by 1.66 times 10 to the power of negative 27. My bad. 1.66 times 10 to the power of negative 27 times 3 times 10 to the power 8 squared divided by, sorry, on that we get 12, then divided by 1.6 times 10 to the power negative 13, you will get the wrong answer. Must have done something wrong. It's wrong. 4.001506 minus 2 protons, 1.007276 plus 2 neutron, 22242. Yeah, that should be correct. 1.008665. Yeah, how is it wrong? 1.66 times 10 to the power negative 27 converted to kilograms times 3 times 10 to the power 8 squared 4 divided by 1.6 times 10 to the power negative 13. Why are you getting 28? Oh, per nucleon. Oh. Wait, no, that doesn't make sense. So let's go back. 4.5. So this is the amount of joules for the whole thing, divided by 6.02 times 10 to the power of negative 23, right? Avogadro's constant. Yes, no, sorry, not. It's just 23. That's for each particle divided by 1.6 and 10 to the power negative 13, and you will not get your answer. Okay, I'm just gonna go get dinner first before I think about this even more, because I must have done something wrong, because it says per nucleon, and I think E is for everything, so once they fill everything, we get the mass of the fact U or whole thing, and times it by 1.66 times 10 to the power negative 27. Maybe per nucleon. Okay, I guess I'll mark it later. So we'll get some dinner first. just had dinner. It's fish. And guess who likes fish? Say hi to the cat. Okay. Oh, it's so cute. She's an old cat. We've had her for like 10 years already. 10 years and above. She's a really cute cat. Alright, so while eating and recharging my sanity, I figured out the answer. So, since it's asking for per nucleon, you will have to divide it. Since helium-4 has four nucleons, which is nucleons are what make up a nucleus. So, proton and neutron. So, yeah, you divide by 4. So, you will get 28.8, of course, as usual. Sorry about that. You get, let's do it again, 2.73. Sorry, 0.030376 times 1.66 times 10 to the power of negative 27 times 3 times 10 to the power of 8 square equals to 4.54. And from that, you divide times 10 to the power negative, divide by 1.6 times 10 to the power negative. No, you can't go on the table. No, don't go on the table. 1.6 times 10 to the power negative 19, you divide it by that. Okay, I'll make space for you. Can I go on the table? There you go. Divided by 1.6 times 10 to the power negative 19, and you get, oh sorry, not 19, since you're finding mega electron volts, divided by negative 30, shoot, my bad, you get, my nose, 28.4 mega electron volts, you divide by, oh my gosh, am I allergic to cats? I'm actually not allergic to cats. Oh my gosh. Okay, so you divide this by 4, you get 7.09. Exactly your answer, 7.09 mega electron volts. There you go. That's why taking a break can really help you with your studies as well. Please don't. Oh, it's climbing on my table now. Okay, you can rest on my table. Isotopes of hydrogen have binding energies per nucleon of less than 3 mega electron volts. Suggest why. Suggest why. She's sleeping. She just fell asleep. She's a pretty old cat, so yeah, she will fall asleep anywhere. Oh, such a cute cat. Suggest why a nucleus of helium-4 does not spontaneously break down to become nuclei of hydrogen. Yeah, I have another cat behind there. It's a small one. It's a younger one. We had her for like 3 years. She's really playful. Suggest why a nucleus of helium-4 does not spontaneously break down to become nuclei of hydrogen. Okay. So, this is because you already know that a helium-4 nucleus has a higher binding energy per nucleon. So, already has high binding energy per nucleon. So it doesn't become a nuclei of hydrogen. Oh my gosh, both cats are on the table now. Because it's already much higher than the binding energy per nucleon of hydrogen. So it won't. It's impossible for it to become hydrogen again because as there is, as it's already broken down to its like smaller, smaller smaller components like the protons and neutrons, which is already 7.19, and that's already much higher than the hydrogen. So that's why it is impossible. That's why it's impossible for it to become hydrogen, because the protons and neutrons already have a higher binding energy than hydrogen. So that's why it's impossible. Okay. Let's move on. Like, let's say if the the binding energy per neutron is lower than 3, like let's say at 1, then it's possible because when it's lower, then it can be in the range of less than 3 mega electron volts. So it is possible for it to become hydrogen. So we'll just write one more as a nucleon is already 7.09. Therefore, since hydrogen is 3 megavolt electron volts or less, it is impossible. Okay, let's mark our paper, and I'm not expecting good marks at all. I have to open up the file first. MS42. Where's my MS? MS. Oh, I only have the QPs. Well, I have to look for the MS now. Oh! I accidentally took the keys off my keyboard. Yeah, the cat's asleep now. That's cute. Milo! Milo! Come here, come here. Physics A-level past papers. CIE. Let's go to 2020 May, June. It's May, June, right? Oh, I didn't write it down. Let's look here. What's it say? May, June. Okay. May, June 2020. I'll just switch the window view over to my browser. Okay. Let's go to the marks key. What's that? 4.2. Okay. So I'll just show you my other cat. Well, this cat doesn't like sleeping. Okay. Hang on. It's raining now. I think that's affecting the cat. Yeah, she's an old cat. Students did not sit exam papers in the June 2020 series due to the COVID-19 global pandemic. Damn. So this paper no one did. And I'm glad no one did this paper because this paper is hard. Work done per unit mass, removing a point mass from infinity to the point. That's 1 mark. Curve from R to 4R, gradient of this decreasing magnitude. Alright. Line passing through 2R plus minus 0.5. And 4R plus minus 0.25. Alright? That's correct. It's not a mark. But I don't get a mark for line showing potential is negative throughout. Because my line is in a positive variable. But what is that? What? Okay. I don't get a mark for that. Since potential has to be negative, yeah, I get that. Negative GM over R. So it has to be negative throughout. Gravitational potential energy is equals to negative GM over R, 1.8 times 10 to the power 10. Yep, I got that. Rock loses potential energy, so kinetic energy increases, so speed increases. That's right. Next one. 2a. Nm over v. I did not write the n, so I do not get it. Stretching out larger. Such a good picture. Okay, I'll stop. She's such a big fluffy cat. Okay, let's move on. Molecules have different speeds, so take average. Alright, you got that correct. One over third. Molecules move in 3 dimensions. You don't like reading this, because I did this paper before already. This is my second time doing it. 1 over 3 more. Reading this, it just comes back to my mind. I feel so stupid for not remembering it. Molecules move in 1 of 3 directions. Okay, and P is equals to NMV. Alright. PV is equity 4.6 times power negative 23, that's correct. So now I've got 3. Little no external work done. Well, yeah, I guess that's true. When you melt something, it doesn't really. There's not really much external work done. Thermal energy supply, okay. But I wrote no thermal net gain because I thought when it melts, it remains at the same temperature. So I guess not. So 3A is all the board wrong for me. There's no external work done, so there's like very little change in volume. And there's thermal energy provided to provide latent heat. Internal energy increases. Rapid increase in volume. Gas does work against the atmosphere. Internal energy decreases. Alright. Hey, stop licking. Hey. The cat keeps licking itself. It's like a clean freak. But it like licks itself too much to the point where it just becomes dirty. Yeah. Stop. And it just licks me as well. Stop. Please stop. Okay, let's continue. 2.9 rats per second. R is equals to. How did I get 3.43? Oh, it's angular velocity squared. I forgot about that. My bad. Stop licking! Just go sleep. It just keeps licking itself. 4b2, 0.087. Okay, that's correct. Smooth wave starting at 3. T0, positions of peaks and troughs show same period, alright. Each peak and trough a lower amplitude than the previous one, alright. 5a, pulses of ultrasound. Ultrasound incident on quartz crystal. It's the principles of detection. So how does it detect the ultrasound wave? So yeah. So there is the pulses of ultrasound, and the ultrasound hits the crystals, which causes it to vibrate, generating an incident, generating a EMF on it, electromagnetic force. My bad. So definitely wrong for that one. Yeah. 5b, specific acoustic impedances. Of air and skin are very different. Okay, I did write that. Intensity reflection coefficient depends on difference between acoustic impedance. I kinda wrote that, but it's not like exact. Most ultrasound reflected, so little transmission. Alright. Radiator bandwidth, no, we didn't do 7b. Force per unit charge on positive charge. So you can't really see the screen here. Right. Force per unit charge on a positive charge. Alright. No electric field inside the conductor. So R is equals to 4.5. Alright. No, my friend just sent me a question, so we're just gonna answer that for now. I'm just gonna show that for you. Let's change the window capture. Alright. So gosh, this is maths. So equation of the curve is x cubed y cubed plus 2xy plus 8 equals 0. Express dy over dx in terms of x and y. Alright, so this one you'll actually do the diffraction using my equations. So firstly you will differentiate x cubed. X cubed differentiate will just be 3x squared plus differentiate y cubed, which would just be d 3 dy dx y squared. Yeah, so for when you differentiate the y, you have to put down the dy dx in replacement of the y. And for 2xy here, it'll just be 2. You have to do the differentiation by parts. So it's like 2 is equals to 2x, y is equals to v is equals to y, and then you differentiate that, so you get v dash is equals to dy dx, and u dash is equals to x. And then you cross multiply and all that. 8, of course, you get nothing. And the tangent to the curve at the point where x is equals to 0, and the tangent at the point where y equals to 0 intersect at the acute angle A. Find the exact value of tan A. So for this one, how do I say this? You have a tangent at the point x equals to 0. So firstly you would do dy dx. Since your dy dx will have like values of y and x, you would first do dy dx equals to where x is equals to 0, and then that will be you have your answer in y. And then next thing you'll do is the tangent at the point when y equals to 0, and you'll do y equals to 0. Intersect at the acute angle at. So from there, since you have the equation of the line and the equation of the tangent of one line, y is equals to dy dx, y equals to mx plus c. Yeah. Okay. And then you'll find the equation of the line. If you find the equation of the line, to find the acute angle, you will actually have to do the. It's not position vector way of finding tangent. Since they're both tangents, one at x equals to 0 and one at y equals to 0, it will be a sort of a it'll be a it'll be a right angle triangle. So yeah, let me show. You have to find the equation of tangent since it is tangent at y equals to 0 and x is equals to 0. It represents a right angle triangle. From there, you find the point of intersection. Do we find the point of intersection? Also, after equation of tangent, equate both. Okay, so we equate both if you want to find the point of intersection. So I don't think the tangents intersect at, let's say you have a 1 at x, y equals 0, x equals 0. So yes, you would have to. So yeah. You need. Wait, sorry, let me look at that. Find the exact, you have to find the point of intersection. So I might have to draw it out for him though. So it's like 1 line, 2 line, let's say x equals to 0. Say it cuts the x-axis here. And let's say it cuts the y-axis here somewhere. So the point of intersection will be here. So point of intersection, and you will know that after you calculate when x is equals to 0, what your y value is, and when your y is equals to 0, what your x value is. What your y value is, so that's your length. So that means that your tangent is opposite over adjacent. So you would naturally have this value, of course, due to it's a straight line. Let's say it's a straight line, and yeah, that's your point of intersection. Oh no. Sorry, I'm not making anything. This is just a conversation within friends. It doesn't mean anything. Let me ask it. You get it? Oh, my bad. That'll be 2x equals to 0. Let me just delete that. Let me draw it again. So you'll have like one line here, let's say. So you'll like have your 1 x is equals to 0. So let's say your x equals to 0. Let's say your line is like this. Okay, x equals to 0. And then your y equals to 0 will be somewhere here. So let's say it's it depends on the curve really. Let's say it's like this. So they'll intersect here. So let's make it easier. Let's say it's y equals to 0, x here, so let's say it's a straight line. So this will be your angle, and this will be intersection. So yeah, the height would be equals to your length here, and your breadth here will be your x value, your x length. Or let's say, I think maybe that's too simple. Let's try. Let's say it's x here, and y equals to 0 would be, say, negative here. So your intersection will be here, and your 90 degrees will be here. So from there, your tangent will be here. Opposite will be here. So to calculate this, yeah, it's basically the same thing. You find the intersection, and yeah, for this one's a bit different though. That's somewhat how it goes. But I will have to do this on paper. But yeah, you just have to find the point of intersection first and find the point. So basically, find the point of intersection, find the point where one tangent cuts, one tangent is x equals to 0, and one tangent is y equals 0. Find their points. Example, 0, and let's say x is equals to 0. 0, 2, 2, 0, say something like that. And the angle should have the lengths on opposite and adjacent. That should be your tan alpha. Yeah, that should be it. Right. Let's move on. Maybe he gets that. He should get it. Okay, next one. We will do 7A. Get my pencil again. Can you stop licking yourself? You've been licking yourself for the past hour. Stop! Force per unit positive charge, no electric field inside the conductor. Oh, I did not give a reason. Oh yeah, wait, no, I did give a reason. You stop licking yourself. Okay, and then your B2, your charge will be 4.1 times 10 to the power negative 7, and I did get that, 4 times 10 to the power negative 7. Stop. 2.8 times 10 to the power 13. Oh, it's correct. So the thing is, don't doubt yourself. Once you doubt yourself, you're gonna mess up. Okay, next one, 8. 8 is not in the syllabus. 9, force is downwards, down the page, current is right to left, so it's downwards, yeah, like I said. So I think the logic is just because like the deflection of the electron is going down, you know? So since it's going down, then that means that the force is downwards, because that's literally, that makes sense. It wouldn't make sense if it's upwards and the electron is going down. And my left hand rule field is, well, yeah, you have to use the left hand rule, but when they asked like to draw the field, I just thought like, how can I draw the field in? Okay. Okay. field is into paper. Field into paper. Okay. And then next one, magnetic force provides centripetal force. Yep, that's correct. 9 times 10 to the power 6. Enough. Arrow showing field direction down to page. So it's down. Yep, my bad. 7.2 times 10 to the power 3. Did I get that? No, I did not. So I can't just use q over 4 pi e naught r squared. So this one, so the thing is q over 4 pi e naught r squared, that's specifically reserved for like spherical charges, not for like fields. For fields, you would have to do like just the normal relating of equations. So BQV is equals to EQ, which is the magnetic force, is equals to the field force of the field. So yeah, from that you'll get this. Yep, so I got that one wrong. BQV is equals to EQ. Next one, straight line, undeviated. Condition for no deflection depends only on V. Oh yeah. Condition for no deflection does not depend on N or Q. Yeah, so the mass of the alpha and the charge of the alpha doesn't really matter. So it's still straight line as well. Depends only on V. Just have to think of the formula, which I really can't think of right now. Oh, sorry. BQV. Wait, no, but it does depend on Q. So hard to do for that. Okay, induced electromotive force is proportional to rate of change of magnetic flux linkage. Okay, that's correct. Shh, stop making yourself. Okay, B1, convert to change of magnitude of potential difference. So it's not convert AC to DC. Okay, next one. To reduce power loss, to reduce eddy currents. Alright. Oh wait, no, I have done B2. Magnitude of EMF varies as rate of change of flux changes. Okay, I did like that. Direction of EMF changes when direction of change of flux reverses. Oh, I didn't like that. Direction of EMF change when flux change. And flux is continuously decreasing and increasing, so polarity of EMF is constantly switching. Alright. Conduction band, no, we didn't do this. Difference between mass of nucleus and mass of nucleons. Alright, so that's your definition. When nucleons are separated to infinity, difference. Okay, so it's the difference between mass of nucleus and mass of nucleons when nucleons are separated to infinity. The first one we got correct. The second one we will get correct as well. Yeah, okay. So we found that 1U is equals to 934, so yeah, my bad. You can just use ratio for this one. So 0.0307376, the mass defect will be equals to 8 times 934. Well, that's the easier way. Divide by 4, since there are 4 neutrons. Yeah. One energy per nucleon is much greater. Okay, I did say that. So it will require a large amount of energy to separate the neutrons in helium. Alright. So that's it. So let's move on to the next paper. I think I'll do the 2023 papers, 4-2-2023. just change the window capture. Alright. So this will be my last paper for today. You, stop leaking. Stop. Chill. Sorry if you start leaking again. Stop! Just sleep. Okay. Let's move on to the next one. Newton's law of gravitation. This one's easy. Newton's law of gravitation states that gravitational force between two point masses is proportional to the product of masses and inversely proportional to the square of separation. Okay, B. A satellite is in a circular orbit around the planet. The radius of the orbit is r and the period of the orbit is t. The planet is a uniform sphere. Use Newton's law of gravitation to show that r and t are related by Gm over r squared is equals to mw squared r. Cancel out the m. Gm is equals to 2 pi over t squared r cubed. Move the r squared over, you get r cubed. So now you have Gm over r cubed is equals to 4 pi squared over t squared. And from here, you move the r cubed over again, but you move the t squared up. So you have stop blocking my view. Gm t squared equals to 4 pi r cubed. Oh, it's so cute. The cat has like a lip, you know. It's like the surrounding layer, the surroundings of the mouth is like pinkish. Looks like it has a lip. Alright. It's just furnace, I guess, but it makes it look like it has a lip. Sorry, it's 4 pi squared r cubed. Okay, next one. C. The Earth may be considered to be a uniform sphere of mass 5.98 times 10 to the power 24 and radius 6.37 times 10 to the power 6. A geostationary satellite is in orbit around the Earth. Use the expression in B to determine the height of the satellite above the Earth's surface. Okay. So the Earth is 6.67 times 10 to the power 11 times 5.98 times 10 to the power 24 is equals to 4 pi squared. Oh, sorry, we wrote t squared yet. Geostationary orbit, so that means that it's 24 hours of orbit. Period is 24 hours, so 3,600. 24 times 3,600 squared, so it's t squared, equals to 4 pi squared r cubed. So to find your r, you have to put r is equals to 6.67 times 10 to the power -11 times 5.98 times 10 to the power 24. What? Times 10 to the power 24 times 24 times 3,600 squared over pi squared cube of everything, which will give you r is equals to cube of 6.67 times 10 power negative 11 times 5.98 times 10 power 24 times 24 times 3600 squared over 4 pi squared. We get 4.2 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 7. So you have to minus this with the Earth's radius, which is 6.37 times 10 to the power 6, to find the height above the Earth. So height is equals to this minus 6.37 times 10 to the power of 6, which gives you 3.6 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. 7. That's the answer. 3.6 times 10 to the power 7. Then I have to do my work on my leg because my cat just took up the whole space. Okay, let's move on. D. Another satellite is in a circular orbit around the Earth, with the same orbital radius and period as the satellite in C. Calculate the angular speed of the satellite in its orbit. Give a unit with your answer. So, the angular speed, about the same as the angular frequency. So, same orbital radius. So it will be 3.6 times 10 to the power of 7. Sorry, I think it's 4.2 times 10 to the power of 7. How will I calculate this? So we have the GMM over GMM over R squared is equals to angular velocity squared R. So we just need the angular speed. Same orbital speed and period. How will I do this again? Okay, so we'll use what we have, where the period is t and the radius is r. So what equation has t and r in it to find the angular speed? Well, I guess if the period's the same, we would have the same. Oh yeah, okay. Yep, angular frequency, and they're different things. So for this one, you will have to use V is equals to angular velocity x naught. So wait, but you have to calculate your. Oh damn. Okay. So you know it has the same period, so your speed will be equals to 2 pi over T, which is 24 times. My cat's scared of the thunder. It's scared of the thunder. It's okay, it's okay. It's okay. It's okay. Times 3,600. And your x naught, your radius, would be what you calculated just now. Because that's the height above your planet. So it would be 3.6 times 10 to the power of 7. Therefore, your angular speed will be equals to. Sometimes you just don't think too hard about your exam too much because you're gonna overthink, and you overthinking will make you conjure up like unnecessary information, which will just waste your time. 2617 meters per second. There we go. Alright. Next one. Despite having the same orbital period, the orbit of this satellite is not geostationary. So from this one, we can straight away already calculate that. We can already, it's just same thing as you would answer a geostationary one, but you'll just give like the opposites. Rotates from east to west, and does not orbit directly above equator. Alright, let's move on to A1. Ideal gas. So ideal gas are gases obey the PV is proportional to T, where P is pressure, V is volume, and T is thermodynamic temperature. Okay, number 2, state the temperature in degrees Celsius of absolute 0, that will be negative 273.15. And B. A sealed vessel contains a mass of 0.0424 kilograms of an ideal gas of 227 degrees Celsius. The pressure of the gas is 1.37 times 10 to the power 5, and the volume of the gas is 0.640. Number 1. The number of molecules of gas in the vessel. So this one you use PV is equals to NKT, capital NKT, because capital N will be the number of molecules and small n will be the number of moles. Which will give you the pressure is 1.37 times 10 to the power 5 times 0.0424 is equals to, and so we just straight away do it, n equals to 1.37 times 10 to the power 5 times 0.0424 over K, which is 1.38 times 10 to the power negative 23 times T, which is 273.50 plus 227, which should give you, oh sorry, why I put 0.0424? That's the mass, 0.640. This should give you 1.37 times 10 times 0.640 over 1.38 times 10 to the power negative 23 times 273.15 plus 227. Should be correct. 1.3 times 10 to the power of 25. There's no unit for this because this is just the number of molecules. Oh, sorry. the mass of one molecule of the gas. So the whole thing is 0.0424. So we'll put 0.0424 over, what was that just now? 1.3 times 10 to the power 25 equals over 1.3 times 10 to the power 25 3.3 times 10 to the power negative 27 kilos. Okay, number 3. Calculate the root mean squared speed v of the molecules of the gas. So the root mean squared speed will just be, hold on, you know the mass, you don't have the how do I do this? So volume mean squared speed v of the molecules of the gas. Let me think. Man, I know there's something to do with the energy. Something to do with half mv squared. How will I put half mv squared into this? Ah, my bad. Sorry. Yeah, don't think too much about it. You just have to refer to the formula sheet. You have the pressure is equals to 1 over 3 Nm over V root mean squared C. That's it. Sometimes, so you don't have to remember all the formulas. Some of it is in this mark scheme. Pressure is equals to 1 over 3 Nm over V root mean squared speed. So what's the pressure? 1.37 times 10 to the power 5 times 3. Move the 1 over 3 over times 3 divided by Nm. So what's your N? your n will be 1.3 times 10 to the power 25. 1.3 times 10 to the power 25. Right? Times the mass. The mass? So is it 0.02424 or is it? Well, I guess 0.0424. 0.0424. Because I kind of feel like it's the mass of one molecule times the. Oh yeah. So it shouldn't be. It should just be 0.0424. Because Nm would be the number of molecules times the mass of one molecule to get the total mass. So mass with volume, you get density. Yeah. Alright. 0.024424 times the volume, which should be 0.640. Yep. Is equals to root mean squared speed, which should give you 3.37 times 10 to the power 5 times 0.640. 0.0424. There it is. 6203773, which is equals to 6.2 times 10 to the power of 1, 2, 3, 4, 5, 6, 6. I feel this is a bit too big for the root mean squared, but it is gas, and gases do move quite fast. Okay, C. The gas in V is now cooled gradually to absolute zero. On figure 2.1, sketch the variation of thermodynamic temperature of the root mean squared speed of the kinetic molecules of the gas. So if you remember, you actually have Ek is equals to 3 over 2 kT. So you have your V squared is directly proportional to your thermodynamic temperature. So as Tk is, so as your T is 500, which you would get from the beginning, which is 273 plus 227, which is 500. Initially, you have the root mean squared speed of V. So let's draw a graph. 500 and V. That's a point there. You start there. Start right here. Sorry. Start right here. And since it's squared, let's say your root mean squared speed is half. So as your root mean squared speed is half, just draw a half V. So since you know it's squared, half square V, you get 1 over 4 V squared. So from that, you get 1 over 4 T, since V squared is proportional to T. So 500 divided by 4, sorry, 1/4 of 500 is, sorry, not divide, 125. So you get it like pretty down here. So it's already all the way to one side, like over here. So like over here. So that will tell you that your gradient is going to be like slanting down a bit. It's not a straight line. It's going to be of a bit decreasing gradient. So let's try to plot another graph. Let's try to plot another point. Let's say 3/4 of your velocity. That will give you, sorry, 3/4. You get 9 over 16 times 500. You will get 281. So 281 will be sort of, since 250 is half, 281 will be like around here. So yeah, around here. So you're going like straight up, down, and such a drop over here. So that should be how your graph looks like. So it's of decreasing gradient. Just like that. So it's like a curve like this. Okay, move on to question 3. State the first law of thermodynamics. First law of thermodynamics, you just put change of U is equals to Q plus W, where change of Q is equals to change in thermal energy. No, sorry, not thermal. Internal energy, and Q is thermal energy supplied to system, and W is work done on the system. Okay, move down, you get B. So A to B, you change in internal energy and work done on the gas. This is 4 marks, so should be 1, 2, 3, 4, just like that. Placing 2 ticks in each row. B to C, decrease, no change, increase, negative, 0, positive. So from A to B, you see that there is a decrease in volume, so that automatically is a positive work done on the gas. Because you are shrinking the gas volume, there is a change in the volume. Final minus initial. Yeah, as long as you shrink the gas, like it's not the gas expanding, work done by, as long as it's not work done by the gas, then it is a positive change. Positive work done on gas. Next one, B to C. There's no change in volume, so you have no work done on the gas. So from A to B, there should, we don't know if there's thermal energy supplied to the gas. So we know that from D to A is 0, since it returns to its normal state, 0 change in internal energy. So C to B should also be 0 change in internal energy. Or not. This sounds pretty tough. Change in internal energy. So how do we know that there's no thermal energy supply? So from A to B, you're just depending on the work done on the gas. No thermal energy supply. So A to B should have no change in the internal energy. No, sorry, positive internal energy. Since you already have work done on the gas, you're not really taking any temperature away from the gas. And B to C would be most likely I would say it's a no change as well, so it's 0 as well. But I think that's wrong. Okay, next one. Use the first law. Oh, wait. Okay, so here you have a increase in internal energy. So yeah, increase. And then once you go through BC, naturally you will have a decrease in internal energy. Here you have another increase in internal energy. And here you would have a decrease in internal energy. So return to 0. You know, but that's not how it works. Okay, let's just stick to what I have. But I'm going to change BC to decrease in internal energy. Okay, next one. Move to. Use the first law of thermodynamics to describe and explain the energy transfers associated with one complete cycle, ABCDA. So, as one complete cycle is done. Uh, System returns to initial volume and pressure. No change in the volume, hence no change in internal energy. Also returns to initial thermal state. No net gain in thermal energy, hence no change to internal energy. Let's move on. 4. 4A1. Calculate the frequency of the oscillations. Hold up. Let me just charge my phone first. Let me take a imperial first. Before I move on to the next question, let me just I need to go and ask something. Yeah, my cat doesn't like to be alone, so when she's alone in the room, she'll just look around a bit because she doesn't like to be alone. Okay, let's move on to the next question. Calculate the frequency of the oscillations. So here you have the 9.7 based on the formula from here. You actually know that this is the angular frequency. So when you have the angular frequency, you can calculate the f. So you know that 2 pi f is equals to 9.7. So f is equals to 9.7 over 2 pi, which gives you hey, don't scratch my paper. That gives you 1.54. 1.54. That's your frequency. 1.54 hertz. That's it. Okay, next one. Show that the amplitude of the oscillation is 3.4 cm. Amplitude of the oscillations. So for this one, you just take the. You just take the maximum oscillation, which is basically the amplitude. X naught is just the amplitude actually. So you have x naught squared. So you'll take x naught squared is equals to 11.6. So x naught will be square root of 11.6, which gives you 3.4. Show. Okay, let's move on to the next one. Calculate the maximum acceleration of the sphere. So maximum acceleration, you will have like a naught is equals to angular velocity squared x. So that gives you 9.7. So x naught, remember, 9.7 squared times x naught, which is 11.6 squared. No, sorry, not squared, just 11.6, which gives you 11.7 squared times 11. Oh, sorry, not 11.6. You already know that the amplitude is 3.4. So 3.4 squared, which is sorry, not squared, times 3.4. 3.9, no, 3.19 meters per second. Oh, sorry, I have to times it by negative 10, 3 times 10 to the power negative 2. 3.4 times 10 to the power negative 2, which gives you 3.19 meters per second squared. You move on from that. B. So for this graph, these graphs are actually quite easy to draw. You stop scratching yourself. It's bad for you. Okay. Draw the graph. You know that its maximum amplitude is a naught. So you would start from here. You will not reach this area. So you know that it's x is equals to 3.4 cm when it reaches a naught. So let's find 3 point. Oh, so you just have to find it in the graph. I don't have to because I'm not using the graph paper. So a naught and 3.4, that'll be 1 point. And since there's no damping, we'll find the other point, negative a and 3.4. 3.4, negative a naught. And it will just be one straight line through the origin. That's it. Straight line through origin. Okay, describe with calculation the interchange between potential energy and kinetic energy of oscillations. So you put like for first C, you state that the total energy in oscillation is constant when amplitude is max, it's at the highest point, PE is max as all of KE is converted to PE. When at zero amplitude, zero displacement, lowest point, KE is max as all PE is converted to KE, and just write down total energy is equals to potential energy plus kinetic energy. Alright. 5A1. The initial charge QA on the plate of capacitor A. So the initial charge in terms of V and C, so it's just CV, that's it. Q is equal to CV. Since it's parallel, they both have the same voltage. And since capacitor A only has capacitor C, then it'll just be CV. CV equals to QA. That's your first answer. Next one, initial energy EA stored in capacitor A. So for this one, initial energy stored, you just put half CV squared. That's it. It's either half QV or half CV squared, since it says in terms of V and C. The difference in mass of nuclei to nucleus, each molecule separated to infinity. Okay, table 9.1 shows the mass defects of 3 nuclei. The nuclear fusion process in a particular star is described by state the name of particle X. So you have 4, 2, 3, 1, 1. You have 2, so X will be a neutron. X is neutral. So that the energy released when one nucleus of 4,2He from this nucleus in this fusion reaction is 2.8 times 10 to the power of negative 12. E is equals to, the M would be 0.030377 minus 0.002388 plus 0.009105 times 1.66 times 10 to the power of negative 27 times 3 times 10 to the power of 8 squared, which gives you 0.030377 minus 0.002388 plus 0.009105 0.018884 times 1.66 times 10 to the power of negative 27 times 3 times 10 to the power of 8 squared, and that gives you 2.82, 2.8 times 10 to the power of negative 12 joules. Okay, let's move on to the next one. The star in B has a radius of 2.3 times 10 to the power of 9 and a luminosity of 1.4 times 10 to the power of 28, all the energy released from the formation of 42He is radiated away from the star. All the energy that's radiated from the star has been released in the formation of 42He. Determine the mass of 42He produced per unit time by the fusion process. Okay, so So per unit time, we actually have 1/4. So 1 second, we get 1/4 times 10 to the power 28 joules of radiation. So this is the energy that is emitted per second. And then we have here calculated the mass defect. So from 142 formation, we get a mass emission of 2.8 times 10 to the power negative 12 joules. So from that we can calculate how many of 42He is being emitted. So we have 1.4 times 10 to the power 28 divided divided by 2.8 times 10 to the power negative 12, we get 1.4 times 10 to the power 28 over 2.8 times 10 to the power negative 12, 5 times 10 to the power 39, and mass of 42He. So this is the amount that is produced in 1 second. So we will have to convert this to kilograms. That's 1.66 times 10 to the power negative 27. That will give us 8.3 times 10 to the power 12 kilograms. That's your answer. Surface temperature of the star. Oh my gosh. Surface temperature, you would just take the luminosity goes to 4 pi stellar, what's that called again? Stefan something, Boltzmann constant, which is 5.67 times 10 to the power negative 8. Alright. Oh wait, we can't do that because we don't have the period. So we can't do that. Yeah, we can't do that. It doesn't state the period, so we'll have to use the relation. So from the relation we have the Wien displacement law is lambda, using lambda. So we know that L. No, we don't have the velocity as well. We can't do that. Surface temperature of the star. Pi. Oh my god. Oh, of course, the T is the temperature, it's not the, this is why you need breaks. Your brain doesn't work right at this time. Oh my gosh, I just want to finish this. Stefan Boltzmann constant, negative 8. And then 4 pi, Stefan Boltzmann constant. And you have r squared, you have r squared, T4. Okay, you have your r squared, which is the radius, which is 2.3 times 10 to the power 9. times 2.3 times 10 to the power of 9 square times T4. So T will be equals to 4, the fourth root of your L would be 1.4 times 10 to the power of 28 over 4 pi 5.67 times 10 to the power of -8 times, what's that, 128? Oh no, that's the radius, 2.3. 2.3 times 10 to the power of 9 squared. So the T should be equals to 1.4 times 10 to the power of 28, 4 pi times 5.67 times 10 to the power of -8, 2.3 times 10 to the power of 9 squared. So that gives you temperature of 6,564 Kelvin. 10A. Let's move on to 10A. State the name of the charged particles that are accelerated by the applied PD, electrons. Explain how the X-rays are produced at the metal target. Electrons of varying PD, acceleration hit metal target. X-rays produce when electrons decelerate, varying deceleration produces varying wavelengths. That's it. Calculate the minimum wavelength of X-rays produced when the applied PD is 5.8 kV. So this would be since electrons we use QV. QV is equals to Hc over lambda. That's the energy of the photons, which is produced. Yeah, that makes sense. Energy of electrons is equals to energy of photons. Yep. Lambda is equals to 6.63 times 10 to the power of -34 times 3 times 10 to the power of 8 over Q, which is 1.6 times 10 to the power of -19, which is the charge of an electron, times the potential difference, which is 5.8 times 10 to the power of 3. Therefore, your lambda is 6.63 times 10 to the power of -34 times 3 times 10 to the power of 8 over 1.6 times 10 to the power of 19. -19 times 3.8 times 10 to the power, 5.8 times 10 to the power of 3. You get 2.14 times 10 to the power of -10. And B. Last question. We calculate the percentage of the X-ray energy that's absorbed by. This one's easy. Okay. X-ray pass through a medium that has an attenuation coefficient of 1.4 cm. Calculate the percentage of the X-ray energy that is absorbed by 2.8 cm. Okay, so your X-ray energy. Can we use lambda for this? No, we can't. Damn. And I just said this was easy. Okay, let's calculate the energy first. So the energy of the X-ray would be 6.63. So let's just calculate the energy of the electron. 10 power times 10 to the power of -19 times 5.8 times 10 to the power of 3 equals to 9.28 times 10 to the power of -16. Okay, so let's say we have E and over E naught is equals to e to the power of the coefficient times the thickness, which will give you E over E naught is equals to E of negative 1.4 times 2.8. That gives you, sorry, not 208, 2.8, that gives you 0.01984. So that's the ratio of the absorbed, that's the one that comes out. So your absorbed energy would be E naught minus E over E naught, which is equals to how do you know the E's? So the E would be 0.01984 of E naught. So you would have E naught 1 minus 0.01984. Yeah, 0.01984 over E naught, and that will give you cancel out the E naughts. 1 minus 0.01984, that will give you 98, 0.98, and therefore it is 98% absorbed. That is a lot. Okay. And that should be it, but I decided to skip one question, so now I will try and finish that question, and I will not mark it today, I'll mark it next stream, and I'm so tired. Okay, so when there's a HC over HC, E is equals to HF, so let's say it's increasing energy, so you have a higher energy here. This is the highest. So there will be a energy of photon is equals to the difference in energies. So over here you have a small difference in energy. So therefore your E equals to HF, you will have a lower frequency. So it'll be, let me draw it up. Sorry, V1. You will have a lower frequency. 1, 2. Label the line A. So let's say it's over here. A. The next one. Draw a line that corresponds to the transition of the free of the electron from n equals 3 to n equals 2. So here to here, even smaller change of energy. So you would have a even smaller further down the line. So first your A will be like somewhere here, B will be somewhere here. Bigger, yeah. Okay, next one. The frequency of radiation represented by line A is Fa. The frequency of radiation represented by line B is Fb. Energy of the ground state, n equals 1, is E1. So let's say this is E1. Determine an expression in terms of Fa, Fb, E1, and time constant H for the energy E3 and the energy level, for the energy E3 of the energy level n equals 3. So n equals 3. So since we have the difference in energy of here, we will also need the difference of energy level of here. So A will have Fa. So let's C. So let's first calculate the energy level of n equals 2. So n equals 2 would be it'll just be Fa, the frequency, Fa. E is equals to HFA. So let's say E2 is equals to HFA. We need E1 as well. So is it E1? Okay, HFA plus E1. because it's the difference in energy level. HFA is the difference in energy level. So if you want to find at the energy level at n equals 2, it will be HFA plus E1. And then you want the energy level of this one. So it will be E3 is equals to HFB plus energy level E2. So it will be HFA E1. So your answer will be H. So it has a plus. Yeah, I've got to go to plus. Yeah, it has a plus here. So we have HFA plus FB plus E1. That should be the answer. And just for that, I'm going to look at the mark scheme. Look at the mark scheme just for that. And it's a high chance that it's wrong. I'm not a very confident guy. Here's QP. What's the MS? Okay, MS. Okay, let's change it. Oh, you can see it. Okay. Let's go all the way down to number 8. I'm just gonna mark that and I'm gonna see. Yep. Okay, so I guess we'll mark from the bottom up. So 98%, that's correct. 2.14 times 10 power negative 10, that's correct. Electron or decelerated, stored or impaired with target, energy lost by electrons emitted as X-ray photon. Okay, that's correct. 10A electrons, correct. So 7,800 K. Wrong, so I got that one wrong, but my method is correct. My formula is correct. Probably just my calculator did something. Probably I just keyed in something wrong. 3.3 times 10 to the power 13. Okay, so I did get that one wrong. So, oh, I forgot the types by 4 since there's 4 atoms. 5 times 10 to the power 39. Okay, I did get that one, so I get 1 mark for that. Times 1.66 times 10 to the power negative 27. Oh yeah, my bad. So I'm supposed to times it by 4. Okay, next one. Uh, 2.8 times 10 to the power negative 12. Okay. Mass defect. Difference between mass of nucleus and total mass of neutrons. Separated to infinity. Okay, that's alright. X is neutron. Okay, now we get to this question. E1 is plus HFA plus FP. That's correct. I'm so surprised actually. B2, larger gap between line B and line A. Line to the left of both pair of A equal 2 and line A1. Correct. Okay, and transmission emits 1 photon with energy equal to the difference in 2 energy levels. Okay, frequency of radiation corresponds to the energy of photon. Okay, I can put that, but I did put transmission emits 1 photon with energy equal to difference, and I'm too lazy to do that now, so I'm gonna go to sleep now. And yeah, that was a great stream. I think I was quite productive. I got 2 papers done, and that's pretty good.